The history of Irish research is one that is at times linked to our nearest neighbour. But the Dublin Institute was one that allowed Ireland to emerge as a leading international research institute in its own right. We have populated that with both Irish people and with internationally renowned people. It has been an exemplar of the way that institutes deal with other institutes around the world. It puts Dublin, it puts the Institute at the very heart of international research.
The greatest ideas in physics of the 20th century were Einstein's theory of gravity and quantum mechanics. We still do not know how they fit together. Einstein didn't like quantum mechanics. He pointed out difficulties with it, which really baffle our understanding. But that's exactly the properties of quantum mechanics, which we now plan to use for a quantum computer. Exactly Einstein's weak points of quantum mechanics should be transformed to one of the major tools of the future in computation.
I'm working on a problem called NAM's conjecture, and it's a problem that originally comes from physics. It arose in the study of conformal field theory, but actually recently it's been related to quite popular things like string theory and M theory, and they're two of the candidates for kind of a new theory of everything. So it is pretty important in physics, and any work we could do on NAM's conjecture would have kind of wider applications. It would be, have applications in conformal field theory, in string theory. As well as that, and the reason I really like working on it is that while it's a problem that comes from physics, it's also related to maths. And not only is it related to maths, but it ties together some very different and kind of very interesting in their own right parts of maths. Okay, the idea of a theory of everything, like who knows whether one will be found ever or not, or even whether string theory is a good candidate for one or not. I wouldn't even pretend to know whether it is. But basically, there are lots of different theories in physics. So you have quantum mechanics, for example, that deals with very small things. You have general relativity that deals with, I think, things that move very fast. But you want a theory that actually encompasses both of them, and none exists at the moment.
The theoretical understanding of nature allows you to do many things, but we're not very practical in that we are theorists. We do the theoretical side of it. We try to understand why the laws of physics are the way they are, what is the simplest formulation of the laws of physics. And over the past 50 years, the laws of physics have been honed down to some very simple, from our point of view, very simple structure. So we understand how to write down the laws of physics in essentially one blackboard. If somebody he understands the code in which it's written, and the code in which it's written is quantum field theory. I mean, we wouldn't expect any of the things we do to have any applications whatsoever. I mean, they may do, they may not do, but once you've understood something, it's very hard to know what someone else will understand that makes it practical to them. Who would have known that a quantum field theory, it now is, of course, the basis for what are hoped to be quantum computers in the future. I mean, I'm sliding over many things, but that's the essence of it.
It is a difficult time in Ireland's history, but no more difficult than it was when this institute first came into being. And we hope that over the next few years, the institute will help in bringing forward new ideas, new research, which will again continue to put Ireland at the very forefront of research.